the surface of revolution, defined as the region under the curve y equal x squared between 0 and 2. It's looking for a rough sketch of the lamina. I'm able to do a little rough sketch. What you can do if you want is maybe plot some points. So it's between 0 and 2, so just a rough sketch should do. You should know that x squared is a U shape. After that, let's see. So y is just x squared. So if we're looking at 0, 1, 2, this would be 0 squared is 0, 1 squared is 1, 2 squared is 4. And we'll do a rough sketch. I do like labels. I think every graph should have labels on it. So let's see. Let's get some kind of a scale going. It's nice to use the same scale, but not completely necessary. So let's say 0, 1, 2, and we need to say 4, 2, 1, 3. Okay. 1, 2, 2, 4. That's a handy scale. And let's look at some points. So 0, 0, 1, 1, 2, 4, and it's a little U shape, bit of a U shape, little parabola. And we're interested in the region under this. Consider lamina defined as the region under the curve between 0 and 2. So it's this little region here that we're looking at. Okay, that is part 1, handy enough. Part 2 says use integration to find the area. So you need to know that the area under a curve is the integral, in this case from 0 to 2, so that shouldn't be too bad. Area is equal to integration from 0 to 2, integrate the function, which in this case is x squared. Nice and handy, to be honest, which as they go. So the antiderivative of x squared is x cubed over 3. Substitute in top limit minus bottom limit, I end up with 2 cubed over 3 minus 0 cubed over 3, which is 8/3. And you could compare that maybe with half the base by the height here. So the base is 2, the height is 4, 2 by 4 is 8, so half that is 4. And this is indeed a good bit less than 4 because the triangle is a little bit bigger. Okay, handy out, this isn't too bad. And then use integration to find the coordinates of the centroid. So on the exam, on the question paper, the following formulas will appear. X bar is the integral of xy dx over the integral of y dx. And y bar is equal to a half the integral of y squared dx over the integral of y dx. Now you already found the integral on the bottom, it's 8/3. Okay, so let's look at this integral, the integral of x, y dx. So the integral x, y dx, we're integrating from 0 to 2, and it's x and y is equal to x squared. Okay, now use our strategy here. You cannot use the tables because they're multiplied together. You can only do term by term if it's a sum. This is not a sum. So what you have to do is do manipulation. X by x squared is x cubed. And then this is an easy integral because to anti-differentiate x cubed, it's just x to the 4 over 4. And then you do top limit minus bottom limit. So it'll be 2 to the 4 over 4 minus 0 to the 4 over 4. And 2 to the 4 is, I think that's just going to give us 4, to be honest. Because this is 16 over 4, is equal to 4. Okay, so that's that. Now we have to find the integral of y squared. Nearly there. But these little integrals here could be more complicated. Usually this requires multiplying out. So the other one is integral of y squared dx. we're integrating from 0 to 2. Y is x squared. This is squared. Now again, you can't do this directly using the tables. It's not x to the power of something yet. So you have to do a manipulation. You have to, now, however way you want to think about it, x squared by x squared is x to the 4. There's different ways of thinking about that. Okay, and this is also an easy integral because it's just add 1 to the power, divide by the new power. Top limit, so it'll be 2 to the power 5 over 5 minus 0 to the power 5 over 5. And this, I think, gives us 32 over 5, which I suppose is 6.4. Well, let's just leave it as 32 over 5 for now. Okay, and now we can use the two formulas to write down the coordinates. So x bar is equal to the integral of xy, which is 4, divided by the integral of y, which is the same as the area, 8/3. And I think that's equal to 3 over 2. Yeah, 1.5. Okay, and y bar is half the integral of y squared, which is 32 over 5, over the integral of y, which is still 8/3. And this is, I think it's like 2 over 15. No, it can't be 2 over 15. There, okay, obviously you can go to the calculator. I'm getting a bit stubborn. 16/5 divided by 8/3. And how this works is, well, there's different ways you can work with it. You could divide above and below by 8, and then multiply above and below by 3, and you'll get 6/5. Okay, so then the final part is to indicate on your sketch the position of the centroid. So 1.5 means it's along here, and that's 1.2, so it's a bit higher than this. So something like that. And that seems to make sense. I suppose on the previous question about the work, did we answer the question that was asked? Yeah, we showed carefully that the antiderivative of that thing was that. Did we determine correct to 3 significant figures? Yes. The work done. Did we state the units? Yes. Then this one, did we roughly sketch the lamina? We did. Did we use integration to find the area? We did. Did we use integration to find the coordinates? We did. Did we indicate on the sketch the position? Well, we're just doing that now. And then the other thing, does the answer make sense? The 8/3 we had to look at, it made sense because of the area. This makes sense, just look at the picture. Yeah, all done. So what you might do is if you get a nonsense answer, like the centroid coming up here, or up here, or over here, or down here, what you just want to say is that, oh, this is wrong. It should be somewhere around here. And that's all. Okay.